Linear regression is a powerful statistical tool used to understand and analyze the relationship between two variables. It is a beginner-friendly method that provides valuable insights into the data and helps in making predictions. Let's embark on a journey to explore the fascinating world of linear regression. Imagine you are in a land where people love ice cream. You know that the amount of ice cream people buy depends on the temperature outside. In this case, the temperature is the independent variable, and the amount of ice cream purchased is the dependent variable. Linear regression helps you understand how these two variables are related. The first step in linear regression is to gather data. You start recording the temperature and the corresponding amount of ice cream sold each day. Once you have enough data points, you enter them into a graph with temperature on the x-axis and ice cream sales on the y-axis. Now, you need to draw a line that best fits the data points. This line represents the relationship between temperature and ice cream sales. Linear regression finds this line using a mathematical formula called the least squares method. It aims to minimize the distance between the line and the data points, ensuring the best possible fit. Once you have the line, it's like having a magical crystal ball. You can now predict how much ice cream people would buy at any given temperature. If the temperature is 30 degrees Celsius, you can use the line to estimate the ice cream sales. Linear regression enables you to make predictions based on the pattern it has discovered. However, it's essential to understand that linear regression assumes a linear relationship between the variables. In our ice cream example, this means assuming that as the temperature increases, the amount of ice cream sold also increases in a steady, linear manner. Linear regression may not be suitable if the relationship is not linear or if there are other factors at play. To assess the accuracy of the predictions, linear regression provides a measure called the coefficient of determination, or R-squared value. This value ranges between 0 and 1, with 1 indicating a perfect fit. For example, if the R-squared value is 0.8, it means that 80% of the variability in ice cream sales can be explained by the temperature. The closer the R-squared value is to 1, the better the model fits the data. Linear regression provides two coefficients, the intercept and the slope. The intercept represents the value where the line crosses the y-axis when the independent variable is 0. In our ice cream example, it would indicate the number of ice creams sold when the temperature is 0 degrees Celsius. The slope represents the change in ice cream sales for each unit change in temperature. Positive or negative slope determines whether the relationship is positive or negative. Now, let's move beyond ice cream and explore other practical applications of linear regression. Suppose you work in a car dealership, and you're curious about the relationship between a car's mileage and its price. By collecting data on various car models and their prices, you can use linear regression to understand how these variables are related. Using the line generated by linear regression, you can estimate the price of a car based on its mileage. Linear regression can also be used in fields like finance, economics, social sciences, and many others. Imagine you want to understand the impact of education on income. By collecting data on education levels and corresponding incomes, you can employ linear regression to analyze and draw insights from the data. It can help you establish whether higher education leads to a higher income. Moreover, linear regression is not limited to just one independent variable. You can consider multiple factors that might influence the dependent variable. This is called multiple linear regression. For example, if you want to predict a student's academic performance, you can include variables such as study hours, sleep, and diet to build a more comprehensive model. In summary, linear regression is a beginner-friendly statistical tool that allows you to understand the relationship between variables and make predictions. It helps you find the best fitting line that represents this relationship. Linear regression can be used in various fields and with multiple independent variables. Remember, learning linear regression opens a door to a world of understanding and prediction. So grab your data, unleash your curiosity, and embark on your linear regression journey.